Let's talk about factoring and simplifying expressions. So I pulled this topic from lesson 6 of Algebra 2B concepts, and it's important. We're going to use this to build on going into further lessons and further topics. We'll grow to dividing rational expressions, multiplying, adding them, subtracting them, and identifying different values within them, and all of that hinges on your ability to be able to factor these expressions and simplify them. So simplifying a rational expression is actually pretty straightforward. We're going to accomplish it by finding common factors of the numerator and denominator and then canceling out those common factors. So this is something you've seen before working with simple fractions. For example, if I had 10 over 50, 10 as my numerator, 50 as my denominator, and I asked you to simplify it or reduce this fraction, you would know that because 50 is divisible by 10, I can split 50 into its factors 5 and 10. If I rewrite the denominator as 5 times 10, with 10 in the numerator, I see that I can pull out this fraction 10 over 10, which is equal to 1. Because anything multiplied by 1 is just equal to itself, I'm able to cancel out these factors, and I'm left with 1/5. So I'm saying 1/5 is the reduced form of 10 over 50. So again, I took the number 50 and I split it into its factors. I found a common factor in the numerator and denominator, and I was able to identify that if I have 10 divided by 10, which is the same thing as 1, this is kind of not necessary in the statement, and I'm able to cancel out these numbers. I'm going to use the same approach when simplifying rational expressions. Now, in order to do that, I'm going to need to be able to factor quadratic expressions. So remember, a quadratic equation is just something written in the form of ax squared plus bx plus c, where a, b, and c are just constant numbers that may or may not be equal to one another. And we must write them in a factored form, x plus m times the quantity x plus n, where m times n equals c and m plus n equals b. Now I know this is a lot of variables and is kind of confusing. We've got about 6 different variables going on here, but it's actually pretty simple once you get the hang of it. So I'm going to show you a method of how to do this. We'll practice it a few times, and once you get a feel for it, you won't need to consult these steps anymore. So let's say you have a quadratic equation, again, ax squared plus bx plus c, where a, b, and c are just numbers. The first step you're going to take is to identify b and c. Next, you'll consider c, and you'll ask yourself, what two numbers when multiplied together equal c? And we're just going to call these m and n. Now, in most cases, there are going to be more than one pair of numbers that multiplied together equal the number you're considering. For example, if c was equal to 12, then m and n could be 3 times 4, or 12 times 1, 6 times 2. There could also be negative numbers involved, so negative 3 times negative 4, negative 12 times negative 1, and so on. So these are going to be your m's and n's. Now, once you've established this list of factors when multiplied together that equal your original number, you're going to select a pair based on b. And you're going to ask yourself, when I add these two numbers together, which one equals b? So for example, if b was equal to 13, I would consider my pairs, and I would say, well, 3 plus 4 is equal to 7. That's not the pair I want. 6 plus 2 is equal to 8. That's not the pair I want. But here I see 12 and 1. When I take the sum, I get 13. So 12 and 1 must be the pair that I want. I'd plug these back into my setup, and now I've just solved for m and n. Let's do a real example here. So let's say we wanted to factor y squared minus 4y minus 12. First thing we're going to do, identify b and c. Remember that a, b, and c are just the coefficients that are attached to each term. So in this case, a is just equal to 1, b is equal to negative 4, be sure to attach that negative symbol, and c is equal to negative 12. So B is negative 4, C is negative 12. So step 1, I've identified B and C. Now I'm going to find products of m and n that equal C. So what two numbers when multiplied together equal C? I'm going to start with 1 times negative 12, negative 1 times 12, 2 times negative 6, negative 6, negative 2 times 6, 3 times negative 4, and 4 times negative 3. So this is my list of products that when multiplied together equal C, negative 12. Step 3, I check to see which sum of m and n equals B. So I have my pairs 1, negative 12, negative 1, 12, and so on. And I check, I'm going to take the sum of each pair and figure out which one equals B, which is negative 4. So for example, 1 plus negative 12 is negative 11. So that's not my pair. Negative 1 plus 12 is positive 11, still not my pair. And I continue checking. You see when I get to the next one, 2 and negative 6, if I add 2 to negative 6, I get negative 4, which is equal to B. So those are the values I want. Now that I have my values 2 and negative 6, I plug them back into this skeleton equation that I've established. So in this case, I would have 2 and negative 6. Now it doesn't matter which one you assign for m and which one you assign for n, right? Because as we know, when you multiply, 3 times 2 is the same thing as 2 times 3. Same thing here. The order of these terms doesn't matter, just the signs. So now we found that x plus 2 times the quantity of x minus 6 is the factored version of y squared minus 4y minus 12, and I always encourage you to double check at the end by foiling your expression. So when I take the first terms and multiply them together, I get x squared, outside, inside, and last. When I simplify this, I do end up with my original expression, x squared minus 4x minus 12. Let's do this again. So this time we're considering x squared plus 6x minus 16, and we'll do the same thing, starting by identifying B, which is 6, and C, which is negative 16. That's step 1. Step 2 is identifying those products of two numbers when multiplied together that equal C, negative 16. So just start listing them, just as before. 16 times negative 1, negative 1 times 16, 2 times negative 8, negative 8 times 2, and 4 times negative 4. And there's no need to rewrite negative 4 times 4. Those are the same numbers. Again, since order doesn't matter, this is kind of redundant to write that last set of terms. Okay, so we go through and we double check, and we ask ourselves, when I sum these pairs together, which one will give me 6 as a result? So starting at the top, the sum of 16 and negative 1 is 15. Oops, this should be negative. There we go. Next I get negative 15. The sum of 2 and negative 8 is negative 6, so we're close, but it's a negative and we need a positive value. Next we sum positive 8 and negative 2. And sure enough, we end up with a positive 6. So positive 8 and negative 2 are the values that we're going to use for m and n. So we have this skeleton structure, and all we do is plug in our values. So again, positive 8 and negative 2. I'm going to FOIL this to ensure that I end up with the expression that I started with. So I multiply the first terms together, the outside terms together, the inside terms, and the last terms, and then I simplify by combining like terms. Oops, plus 6. And sure enough, I end up with x squared plus 6x minus 16. So at first I know these steps may seem a little bit tedious as far as listing all of the pairs that were, when multiplied together, were equal to negative 16 and then scanning them to find a sum that would equal 6. But as you go, it becomes more and more intuitive. So right away you probably could have anticipated, well, I know I need to end up with this sum of 6 in the end. So you may not have even bothered to write down the pair of 16 and negative 1 because you know that there's no way to combine them, whether they are positive or negative, to end up with that value that you wanted for b. So again, as you practice more and more, it becomes easier and easier to kind of intuitively select the pairs that are going to work. Now, that's just factoring a simple expression. In your lesson, you'll be asked to take a look at a rational expression, which is the quotient of two polynomials. So quotient meaning that we're going to divide, polynomials being terms of one or more expressions of one or more terms. So in this case, I have a trinomial in the numerator and a trinomial in the denominator. I'm going to simplify this just as we did before. I used the example of 10 over 50 and simplified it to 1/5. We're going to take the same approach here. I'm going to factor the numerator, factor the denominator, look for common factors, and then cancel them out. So step 1 is just factoring each piece. So let's start with the numerator. X squared plus 13x plus 42. So I always start by writing out my skeleton. I know I'm going to end up with an x on the left-hand side of both factors. What will be on the right-hand side? So just do some mental math here and consider how we could split up 42. I know it could result in a pair of 6 and 7, of 2 and 21. Ask yourself what's likely. Remember, we want the sum of these two numbers to end up being 13. So which pair might give us that result? So I think it's easy to see that the pair 42 and 1 or 21 and 2 are probably pretty unlikely. 6 and 7, if you'll notice, 6 plus 7 is equal to 13, and that does end up being the pair I'm going to use. So I put 6 and 7 on the right-hand side of my parentheses. The last thing to double check before we move forward is just what kind of signs you're using. Since we have addition in both places, I know that I'm going to have an addition sign for both factors. So now I've got the numerator. Moving on to the denominator, I'll take the same approach. So again, I like to just write out that skeleton with the parentheses and the x's already in place, and then I consider c, the number on the right-hand side. Well, in this case, we have 7, which is the prime number, meaning that there's only one way we can do this, 7 and 1. There's no other way to split up 7 into two whole numbers that when multiplied together would give us 7. Again, I just need to double check my signs. And once more, I have addition in both places, so I know that I'm going to have addition in both factors. So I'm going to pause here. So far, I have factored the numerator and factored the denominator. I'm going to take a second to re-examine this question. Notice that it asked me to identify any x values for which the expression is undefined. So all they mean by that is what values of x cause the numerator or cause the denominator to equal 0. Remember, we can't divide by 0. This statement just doesn't make sense. So for example, if I had 2 over 0, that doesn't really hold a value. It doesn't hold a meaning for us. So we need to know what values of x are going to cause that to happen, and we're going to call our function undefined for those values. So I consider my denominator, and I'll split each term and consider it separately. So I have x plus 1 and x plus 7. I want to know what value for x will cause the equation to equal 0. So I set each term equal to 0 and solve. In this case, x plus 1 equals 0. If I solve for x, I get x equal to negative 1. For x plus 7, I get x equal to negative 7. So these values are undefined for this function. X cannot equal negative 1 and cannot equal negative 7, otherwise I get a 0 as my denominator, which is an undefined value. Now going back to our simplifying process, we have our numerator and denominator written out in factored form, and now all we have to do is look for spots where we have the same term in the numerator and the same term in the denominator. So probably what's jumping out at you is that we have x plus 7 present in both the numerator and the denominator. So I can cancel out these terms and rewrite my expression simplified as just x plus 6 over x plus 1. My full answer with the simplification and the identified undefined x values would be x plus 6 over x plus 1, where x cannot equal negative 1 and x cannot equal negative 7. Let's do another example. So same thing here. We're going to simplify by factoring and canceling like terms in the numerator and denominator. And we have to pause and identify what values of x cause the denominator to equal 0 and therefore would be undefined values of the function. Alright, so starting with the numerator. Start by writing out your skeleton. So we have our two sets of parentheses, we have our x's in place. Now consider c, which in this case is 2. Again, we have a prime number, and anytime we have a prime number, we know there's only one way we can write the numbers, just simply the number by multiplied by 1. There's no other way to split 2 into two whole numbers. That one multiplied together will give you 2. So we've got 2 and 1, and now we just need to figure out our signs. Since we've got addition going on in both places, addition is going to be the appropriate symbol for both factors. What about the denominator? Once again, putting down our framework, consider negative 6, and then ask yourself what values, when multiplied together, would equal negative 6. So we've got negative 6 and 1, positive 6 and negative 1, negative 2 and 3, positive 2 and negative 3. Now, I want to add these so that when they are added together I get negative 5. Well, it looks like negative 6 and 1, negative 6 and positive 1, give us negative 5, and again, when multiplied together, they equal negative 6, so that's the pair we're going to use. Again, it didn't matter if I wrote the negative 6 first, or the negative 1 factor, or the positive 1 factor first. It's equivalent either way. Now I'm ready. I've factored. I'm ready to take a pause and identify which x values would cause the expression to be undefined. Remember, that means I just take the denominator. I consider each term separately, set them equal to 0, and solve for x. In this case, I get x as negative 1 and positive 6. So that tells me for the value x equal to negative 1 and x equals 6, positive 6, my expression is undefined. So that's half my answer, but I'm not done simplifying. So reconsidering this factored expression, I see that I have x plus 1 as a factor in the numerator and the denominator, so I can cancel it out. And my final answer would be x plus 2 over x plus 6 is my simplified expression, where x cannot equal negative 1 and x cannot equal positive 6. So again, I have my simplified expression, and I have identified the values for x that would cause the expression to be undefined. Alright, last practice here. Same thing. We're asked to simplify and identify the x values that cause our expression to be undefined. Start with the numerator. Write out your skeleton. Figure out the values that go on the right-hand side. So 4, our only two choices are a pair of 4 and 1 or 2 and 2. In this case, I know that if I write negative 2, negative 2, negative 2 times negative 2 is positive 4, which is the value I want for C. Negative 2 plus negative 2 equals negative 4, which is the value I want for B. Let's tackle the denominator. Once again, setting up the framework. Consider your 6. I've got either a pair of 6 and 1 or a pair of 2 and 3. Notice that I need B to be negative 5. I need the sum of these is going to be negative. Now, what does that say about the signs here? Because I know when I multiply them together, I need to get a positive result. So that tells me that both of these are going to end up being negative. So negative 6 minus 1 equals negative 7, so that's no good. But negative 2 minus negative 3, or plus negative 3, is equal to negative 5, which is what I wanted. So I'm going to use -2 and -3 as my values for m and n in the denominator. And remember, you can always pause and double check these by foiling to ensure that they're being done correctly. Alright. Now take a quick moment to consider the denominator and figure out the undefined values. So again, take each factor in the denominator, set it equal to 0, and solve for x. In this case, x is undefined, or the expression is undefined when x equals 2 or 3. All that I have left to do is simplify my expression. Now notice that I have two factors of x minus 2 in the numerator. These, just based on this alone, would not cancel out at all. You must have the factor, as we do, in the denominator to actually do the canceling. So I'm going to cancel out my one factor in the numerator with one factor in the denominator. And this one does not get canceled out. So I'm left with x minus 2 over x minus 3 as a simplified expression, where x cannot equal 2 and x cannot equal 3, because those are the expressions, or the x values for which the expression is undefined.